Good afternoon, students. So this is Manoj Kumar, Assistant Professor from Kalpataru Institute of Technology. So we are giving the lecture on some of the machine learning algorithms. So in the previous video lectures, we have gone with various supervised and unsupervised techniques or machine learning algorithms like Bayes theorem, decision tree, k nearest neighbor, and previously we have gone with artificial neural network also. So in this particular session, we will go with a new concept, that is support vector machines. So what is this support vector machine are called? So what is this concept that we will see here? Okay, so what is the goal of the support vector machine means to create a flat boundary called hyperplane, which divides the space to create homogeneous partitions on either side. So it creates a boundary. So what is that boundary called? That boundary is called as a hyperplane, which divides the space into homogeneous partitions. Homogeneous means same partition on either side. So what does it combines? So it combines k nearest neighbor plus linear regression. So what is k nearest neighbor? So you will be finding which is the nearest neighbor that we have gone with as a video lecture, that is a nearest neighbor algorithm, and regression concept also. So linear regression means everything will be in the form of the straight line, y is equal to mx plus c. You are combining both to form the support vector machine. So what are its uses? Now you see this one in this diagram, this is the input space. Okay, so this you are having red colored samples as well as violet colored samples. So for this, now you see I'm represent that in the form of 3D representation. So first you are having all the red at the bottom, and at the upper level you are having all the violets. So in between, so all red form a homogeneous partitions, all violet will also form a homogeneous partitions. In between those we create a space, so that is called as a hyperplane. So hyperplane is what you have in green color plate, that is divided, which divides the homogeneous partitions, that we call it as a hyperplane. So where these are used, so it is used for the classification, numeric prediction, and pattern recognition. So understanding the support vector machine means it creates a boundary which divides the homogeneous partitions on either side. So come for the application where they are used. So one is classification, number prediction, and pattern recognition. So first is classification. In the field of bioinformatics to identify cancer. Next, text generation used in the document classification. So detection of rare events. So like security breaches, earthquakes, everything. Now you come for what is hyperplane. Okay, so hyperplane means it is a boundary which partition data into similar class values. It is a boundary. It is used to partition data into group of similar values in two-dimensional. So matrix, this is in the form of 3D cube. If you go with the 2D dimensions, so we have taken in the form of the 3D cube. Now you come for the 2D dimensions. Used to identify the line that separates the two classes. This one you consider it as red. This one you consider it as violet. And in between there comes a identify the line. So that is hyperplane. Hyperplane in 2 dimension is given as hyperplane in 2 dimension is given as a straight line, whereas hyperplane in 3 dimensional cube is represented as a cube, okay, with 4 faces. So this is the hyperplane we can consider in 2 dimensional. More than one choice of dividing line between the group of circles and squares. So we can have more. What is hyperplane? Here you see you can have a cross line, or you can have more than one choice of dividing the lines between group of circles and squares. This is group of circles, so this one is group of squares. We can have more than one choice of dividing the hyperplane, so that I have given like this. So there are 3 hyperplanes here. So 3 such possibilities are labeled A, B, C. So how does the algorithm choose? So it chooses maximum margin hyperplane. So what is the algorithm we are using? So to choose the hyperplane, it is a maximum margin. So which one is having maximum margin between one group than we have, which is the other group. So maximum margin which one is having, that we consider it here. Okay, so you should be not too close to each and every group. Okay, you should be having a maximum margin between that two groups. So take it here, class 1, here it is class 2. So here to here there is a maximum margin, here to here also there is a maximum margin, that type. Okay, so now you come for the maximum margin hyperplane. So what is this maximum margin hyperplane? Creates as the greatest separation between the two classes. It creates the greatest separation between the two classes. So what is it? Points from each class that are closest to MMH. What is MMH? Maximum margin hyperplane. So points from each class that are closest to MMH. Use the support vectors alone. It is possible to define MMH. Okay. So now you see here, so which is the very nearer support vector? So this one very nearer to MMH, this one is the support vector which is very nearest to MMH. So these are the support vectors which are very nearest to MMH. Okay, so it is possible to define the MMH here. So that is the concept on support vector machine. So support vector machine means it consists of a hyperplane which partitions the data of similar classes. Okay, so this is now we can easily understand what is support vector and what not, which is the nearest one. So it creates a greatest separation between the two classes. One is support vector and this one is the support vectors for the circle class and this one is the support vector for the square class. So come for the next one, that is up to supervised learning algorithm. Now you come for the unsupervised learning algorithm that we will see in today's class, that is clustering. So clustering is the unsupervised learning algorithm. It mainly deals with finding a structure in collection of uncategorized data. Understand very carefully. It deals with finding a structure or a pattern in a collection of uncategorized data. Okay, so process your data and find natural clusters if they exist in the data. So see, this is the sample I have taken. So cluster or group means you are creating the different groups of same type of item, different groups of same type of item, that is called as a cluster or a grouping. So this in this sample you are having black, pink, white, everything is mixed here, but you come for the cluster here, each and everything is created a group if they exist in the data. So what it will do, input is already sample is given, you are making it separated. Okay, that comes under unsupervised learning algorithm. So unsupervised learning means no input, no output, no x, no y, nothing will be there. It deals with structure or a pattern in uncategorized. There is no category here. All pink category are coming here, or white categories are coming here, or black categories are coming here. So everything is uncategorized sample. So that uncategorized sample that we will process and find natural clusters if they exist in the data. Okay, so now come for the next, that is unsupervised learning algorithm. Next we go with evaluating the model performance. So how do you evaluate the model performance? So that we go for the concept called confusion matrix. So what is a confusion matrix? So confusion matrix is a 2 cross 2 matrix which tells the performance of the model what you have designed. So it is a process of evaluating machine learning models. It has varying strengths and weaknesses. Test should distinguish among the learners. So what is a confusion matrix? So a table that categorizes the predictions according to whether they match the actual value. Categorize the predictions according to whether they match the actual value. One dimension you have predicted class values, the other dimension you have actual class values. So mine actual class values are 1 and predicted class values are 1. So that we call it as a confusion matrix. So into one dimension, it's the predicted class values. The other dimension, we consider it as actual class values. So these are the A and B are the, if it is actual, if it is predicted actual value class and predicted class should be same. Then only we can tell the performance is good. If both are different, then we can't tell. If here you say actual class is circle, but predicted is into. So that means the matter they both are wrong. Okay. So now how you evaluate the model performances? So 2 cross 2 confusion matrix for a two class binary model. So it's actual. So correct predictions. So predicted value is equal to actual value. It is a correct classification. Okay. So the diagonal elements in the confusion matrix denoted by O. So if the predicted value is equal to actual value, so predicted value is equal to actual value, and then it is called as a correct classification. If the predicted value differs from the actual value, where predicted is differs from the actual value, then it is called as an incorrect prediction. So it is called as a misclassification. So of diagonal matrix cells. So come for the positive class. So in confusion matrix, the class of interest is known when both are classified. So if there is a correct classification, it is called as a positive class. If there is an all others are called as misclassified or called as a negative classes. So the prediction falls into one of the four categories. So true positive TP, that means predicted is also, sorry, actually is true, and predicted if you got it as positive, then it is called as a correctly classified. So that is TP. So if they expected and predict, if the actual value is true and you predicted is also true, then it is called as a correct classification. If the actual value is true and your predicted value goes negative, then it is called correctly classified as not the class of interest. So false positive means it is also incorrectly classified. False negative also incorrectly classified. So using confusion matrix. So using in confusion matrix, you can find the accuracy. So accuracy of how much the predicted class is. Okay. So accuracy of how much the predicted class is. So that we will be taking using formula. Accuracy is equal to TP plus TN divided by TP plus TN plus FP plus FN. Okay, so these are some of the concepts you are having. First one is accuracy and next one is error rate. So accuracy is equal to TP true classification divided by true plus false classification. TPTN are called true classification. TPTN, FPFN are called true and false classification. Error rate. So error rate is equal to 1 minus accuracy. So how you find it is FP plus FN divided by everything. So just you compare accuracy with error rate. Here it is TP plus TN. Here it is FP plus FN. So that is TP plus TN by all. So but accurate error rate FP plus FN by all. A model is correct 95% of time, is incorrect 5% of time. So next, model performance, you get some other concepts, that is precision, recall. So okay, so precision and recall. So positive samples. Precision is equal to TP by TP plus FP. This is the formula. So recall, so in place of FP, precision, same thing, but in place of false positive, here you take false negative in recall. So here in precision, it is precision is equal to TP by TP plus FP, but whereas in recall, it is TP, recall is equal to TP by TP plus FN. Okay. So next you come with the new concepts. So that is in new concepts. First you see, so how in clustering, how you are going to do? So training the procedure of partition, how you partition the data depending on training data and testing data. So training means both the input and output are also there. But testing means input is there, output is not there. So that one we call it as testing data. So training data set means input with output, everything is there. So using that, we have to test the data set. So in testing, input will be there, output will not be there. Okay, so for that, next you come for the validation data set. It is used for refining the model. Okay, so training data set 50%, testing data set 25%, validation is 25%. So now you come for the holdout method. So training and testing is there. So original data is this one. So training data and testing data will be there. Again, training data is divided into training data and validation data, and the testing data will remain same. Okay, so this is the raw data. So matrix will be there. So matrix will consist of training data as well as testing data. Take the part, training data goes there, testing data is here. So training data will undergo model A, model B, various clustering algorithms. So after clustering algorithms, you go with the best model and evaluate the model. So evaluate, you will be getting the accuracy matrix. So TP, TN, FP, FN, we call it as accuracy matrix. So now you, after that, now you go with the next concept, improving model performance. Model evaluation is finished. Now we shall go into the model performance. So that concept that we will see in the next coming tutorial. So understood what is clustering. I hope you all got understood the what is clustering and what is support vector machine and what is accuracy, precision, recall and all. Just you have the concepts in your mind, so it is more than enough. Okay, so up to here will be the this particular session. So I hope you understood the basics of the machine learning. So this machine learning concepts is going to complete it here. Okay, these are the basics what you have seen. I hope you enjoy this particular lecture. Listen the concepts carefully. Okay, understand the concepts is more than enough. Okay, so I'll be ending this particular lecture. If any doubts, you can ask me in the comment box. Okay, so kindly subscribe for the video and you will be getting more lectures after this. Okay, so I'll be ending this. Kindly subscribe for the channel. Thank you. Be safe, be secure.